Hello there, welcome back for another great lesson of mathematics. All right, so my throat's kind of been a little sore, so I'm recording this video in case I don't have any voice in class. So, what are we going to learn about today? Well, we should have done this warm-up together as a class on the first page of your new notes packet. So we're going to skip down to the bottom of the page and we're going to talk about something that I'm sure you are just so excited about, and that is long division. All right? Yeah, I know. You're so excited. You're welcome. Okay, so what I'd like you to do is take a little trip back in time, and I want you to use long division to divide 65,180 by 8. All right? So I'm going to pause this while I do my work. You do yours, and then we'll come back in a moment and compare notes, all right? Okay, see you back here in a minute. So let's see how you did. I took 8, divided it into 65,180, and I got 8,147 and 4/8, which is really 8,147.5. All right, and we're going to check on my calculator to see if that's right. So 8 times 8,147.5. Sweet. Now notice I divided over here and I used multiplication to check to see if it was right. That's because those two are inverse operations. Let's not forget that word. That's very important. All right. Before we get into our actual example that relates to class today, I want you to notice a couple of things. You picked values, like at no point in time did we try to figure out the one, like the 8,147. We took it one piece at a time, okay? And that's very, very important. We took it one number at a time. First, you probably just looked at could 8 go into 6, then 65, then dealt with that. Then the number totally changed. It was 11 we were trying to figure out, and then 38, and then 60, and then et cetera, et cetera. And we carried down one part of this factor, or this number, each time. Same thing is going to be true in the long division we're going to do with polynomials. And some of you may be saying to me, or saying to yourself, but God, like, why can't I use my calculator? That'd be really great. Well, your calculator doesn't know how to function when you're dealing with a variable. So you are going to have to be a bit smarter than your calculator. I think you can handle it. All right, so here's what we're going to do. We are going to take this polynomial, x minus 2, and we are going to divide it into this larger polynomial, 8x cubed, hold on, x cubed plus 2x squared minus 6x minus 9, okay? And just like in the long division up here, we're going to take it one term at a time. So first, all I care about is how do I get rid of x cubed. I don't care about anything else in the problem. I just care about the x cubed. So I want to think about how can I multiply x, or what can I multiply x by? So here, make yourself a little note. What can I multiply by to get rid of, and then fill in the blank. In this case, we're trying to get rid of x cubed with subtraction. Well, if I take x and I multiply it by x squared times x is x cubed. Now, here's the one thing that is different. Up here, okay, there's only one term, right? 8 is one thing, okay? Here, that's not true. In the yellow highlight, you can clearly see there's an x and there's this negative 2. You distribute 8 to 8 to get 64. That's how that works. And you only have to deal with that once. The problem is we don't have that luxury here. We have two terms, we have to distribute, we have to be fair. So that means a byproduct of getting rid of x cubed is that we're also going to get negative 2x squared. Okay? Sorry. I don't mean to cough in your ear. All right. Then if you notice, after you multiply, you subtract. So multiply, then subtract. all right? And you want to think about it more like switching the signs. Here's what I mean by that. I'm going to subtract, all right? But really when I subtract, this is a positive term, so I'm switching it to a negative. Here, I'm switching this negative to a positive, right? Because I'm subtracting a negative. So that first term cancels out. And then I get 4x squared left over. Now remember, I'm supposed to carry down the next term, just like I carry down the next number up here. All right, so this is going to be negative 6x. So now I'm asking myself, what can I multiply by to get rid of 2x, no wait, to get rid of 4x squared? Well, that's x, so I'm definitely going to need a 4, and I only have an exponent of 1 here, so if I do 4x times x is 4x squared. And then remember, as a byproduct, 4x times negative 2 would be negative 8x, okay? And then I am going to multiply, then subtract, switch the signs. So this becomes negative, and this becomes positive, all right? So that cancels, and I'm left with, it looks like 2x minus 9. Okay. Oh, because I took this 9 and I dragged it down. All right, so how do I get rid of 2x when I have an x? Well, I'm going to multiply by 2. And, sorry, the pen is just too thick. Okay, and then 2 times x is 2x. 2 times 2 is 4, so that's a negative 4. And then I'm going to subtract. All right, these cancel, and I'm left with, oh, wait a minute. Did I switch my signs? I got negative 2, and when I subtract, I should get positive 2. Do you see how easy it is to forget because you get so excited that something's going to cancel? So we should be left with negative 5. So my final answer is x squared plus 4x plus 2 with a remainder of negative 5. Okay? Now, we could check our solution by multiplying the divisor by the quotient and adding the remainder. I'd love it if you could do that on your own. I want to make sure I have enough time to do at least one more example with you, but that would be a great thing to check your answer. Okay? So, if you take a look at this problem, like I said, I want to walk you through at least one more example. So, similar setup, right? I've already got the division going. I've got 2x plus 3, that's what I'm dividing by, and I've got 2x cubed, got my 4 terms inside. Okay? Actually, I think I'm going to deal with, give me one second. Let me see what options we've got. Yeah, I'm actually going to skip to this one for 2 reasons. The first reason is that it's not set up, and I want to make sure I show you how to set something up. And 2, you notice there's only 2 terms here. I want to address something going on in there. Okay, so A minus 5 is what we're dividing by, so that goes on the outside. And then inside, I want you to notice, that's quadratic, right? So normal quadratic, ax squared plus bx plus c. Do you see how we've got something squared and a number but nothing in the middle? Well, what that means is you need to leave yourself a placeholder for 0 a's just in case you have something come up. So make a little note that this is a placeholder, okay? It's totally possible that you'll have a need for one as you're dividing, all right? I imagine that's going to come up in this problem. Okay, so remember the rules. First rule, what multiplies to get rid of the first term? So a times an a, that would get me a squared. And then as a byproduct, do you see how I have this negative 5a? I wouldn't have had a column for it if I hadn't left this placeholder here. So that really helps me out. Now, remember I subtract, which means I switch the sign. Okay, so the negative became a positive. So those cancel, and now I'm left with 5a minus 28. Now to make this a, which has a 1 in front of it, 5a, I would multiply by 5, right? So that would get me 5a minus 25. I was thinking plus because I know it's going to switch signs. Okay, so that's going to leave me with negative 3. So it looks like I have a plus 5 as my answer with a remainder of negative 3. All right? Okay, let's see if there's one more that I'd like to do with you. Oh yeah, we'll do this one, problem number 5. So I'm sorry I'm kind of flipping around here on you. I just want to do some of the more challenging ones with you. Okay, so once again, this isn't set up. More importantly, it's not even in order. Remember that you always want to write terms in descending exponent order. So you want to put the variable first. So let's do k and then minus 1. And then it looks like k cubed, that second term, that's really what should go first. And then negative 5k squared. And I'm just crossing these out so I know I've already used them, so I don't write them twice. 8k and then plus 4. All right, cool. So now that I've got this all set up, let me get my pen out. Okay, so again, what am I going to multiply k by so that it looks like k cubed? Well, what about k to the second power? Because, right, 1 plus 2 would get me 3. And as a byproduct, I would also get negative k squared. All right, I hope you're thinking to yourself, now I have to switch the signs. All right, so those cancel, so I'm left with negative 4k squared. Drop down my next term. All right, now we haven't gotten this before, but you see this number? It's negative. You want to multiply by whatever you see. So if you see a negative, you multiply by a negative. So negative 4k, right? Because I need 1 and 1 to make 2. All right, so negative 4k squared, and then it looks like I'm going to get a positive 4k, because a negative times a negative makes a positive. So the signs switch. That should really be minus. 8 minus 4 is 4. Right. Looking good, looking good. Okay, another 4, it looks like, is what we're going to need. So 4k minus 4. It looks like this is going to cancel, but the signs switch. So I'm left with 8. So it looks like we have k squared minus 4k plus 4 with a remainder of 8 as our answer. All right? So basically we're just practicing different types of long division. You've got the rest of class to work on the problems, up to problem number 6 and any problem we didn't do before that. All right? So ask questions if you have any. Otherwise, thanks for listening. Bye-bye.